Hey guys, it's Mr. Brengle, and today I'm going to be going over the review math problems for the speed and acceleration test. So this first problem here, it says a jumbo jet is traveling at 35 meters per second and needs to stop. What is the acceleration of the plane if it takes the pilot 2.5 seconds to bring the plane to a halt? Okay, so the first thing that we want to do here is identify what we've been given. And in this case, it tells us that the jumbo jet is traveling at 35 meters per second. So that would be its initial speed. And it says it needs to stop. So that's telling us that the final speed is going to be equal to 0. And then it also tells us that it takes 2.5 seconds for the plane to stop. Now, our unknown here, circled it over here, is acceleration. It says, what is the acceleration of the plane? So acceleration is equal to question mark. And then the units for acceleration are going to be meters per second squared. Make sure you get that squared in there, because otherwise the units will be meters per second, which is what we use for velocity and speed. Okay, so the equation that we want to use here, acceleration is equal to the change in velocity over the time that it takes. So now we can go ahead and substitute in our variables here. So acceleration is equal to our final velocity, which is 0, minus our initial velocity, which is 35 meters per second, over 2.5 seconds. So make sure that when you do this, you are paying close attention up here, because this is 0 minus 35. So that means that my acceleration is going to come out negative. And if you're just thinking, oh wait, is it supposed to be negative? Think about what the object in the question is doing. In this case, it is slowing down to stop. And so it will have a negative acceleration. So we'll do negative 35 divided by 2.5, and that comes out to be negative 14 meters per second squared. All right, let's go ahead and move on here to our second problem. Okay, so this problem says the Kentucky Derby, the first of 3 horse races for the Triple Crown, was won on May 7th, 2000 by Fusachi Pegasus with a time of 121.1 seconds. If the race covers 2011.25 meters, what was the average speed? So this one is asking us for the average speed, and you can see that it's given us a time and a distance here. So this problem is different than the last one. So for our givens, we know that the time that it takes is 121.1 seconds. And we also know that the distance covered is 2011.25 meters. The unknown, it asked us what the average speed was. So v is equal to question mark. And we know that this is going to be in meters per second, because we use meters in our distance and seconds in our time. Now the equation that we want to use here, v equals d over t. So now we can substitute in, and we'll say v is equal to 2011.25, whoops, not great there, 0.25 meters divided by 121.1 seconds. So when you put that into your calculator, you should get 16.6 meters per second. All right, so we will now move to our third problem here. In this problem it says that Elijah is pushing a shopping cart at a speed of 1.5 meters per second. How long will it take him to push the cart down an aisle with a length of 9.3 meters? Okay, so I've underlined the two givens, but to find the unknown, sometimes people will get confused because it says how long, and people think, oh, well, that's the distance, but it says how long will it take him to push the cart. So this is asking for the time here. So for our givens, it gives us speed is equal to 1.5 meters per second. And then it also gives us the distance that's equal to 9.3 meters. Our unknown time, this is going to be in seconds. We see that right here with our speed. It's given to us in meters per second. Once again, we'll be using the equation V equals D over T, but this time, since we're solving for T, we're going to have to manipulate this equation a little bit. So I want to get T by itself, so I need to multiply by T on both sides to get that out of the denominator here and onto the other side. So now I have TV is equal to D, and again I want to get T by itself, so I need to divide by V to get that off of this side, and I need to do that on the other side as well, and then that gives me the correct equation, which is T is equal to D over V. Okay, so now we can substitute everything in. So time is equal to the distance, which is 9.3 meters, over the speed here, which is 1.5 meters per second. So plug that into your calculator and you are going to get a time of 6.2 seconds. Alright, let's move on to number 4. Okay, so it says a runner covers the last straight stretch of a race in 4 seconds. During that time, he speeds up from 5 meters per second to 9 meters per second. What is the runner's acceleration in this part of the race? Okay, so this is another acceleration problem. So in this, it gives us 3 things here. The first thing is it says the time that it takes is 4 seconds. And then it gives us 2 speeds. One of them is the initial and one of them is the final. Since it says he speeds up from 5 to 9, we know that our initial speed is equal to 5 meters per second, and final speed is 9 meters per second. The unknown here is acceleration, and that's in meters per second squared. So we'll use our equation for acceleration, change in speed, or VF, the final speed minus the initial, divided by the change in time. So when we go to plug everything in here, the acceleration will be equal to the final speed, 9, minus the initial 5 meters per second, over 4 seconds. So when you solve this, you should get 9 minus 5 is 4, so 4 divided by 4 is 1 meter per second squared. Alright, let's move on to our last question here. Number 5. A runner ran his last race in 9.58 seconds with an average speed of 11.2 yards per second. How far did he run? Okay, so we'll go to our givens here, and it does give us a time, 9.58 seconds. And then it also says that he has an average speed of 11.2 yards per second. Our unknown here is distance, how far did he run, and this is actually going to be in yards, and that's because you can see here in our speed it gives it to us in yards per second, so when we cancel everything out we're going to be left with yards. So our equation here, V equals D over T, but we are solving for D, so we want to get that by itself. To do that we need to get T out of the denominator. So we multiply by T on the right side, got to do the same thing on the left side. So this leaves us with D is equal to T times V. That is what we want to use here. So now we can substitute our values in. Distance is equal to our time, which is 9.58 seconds, times the speed, which is 11.2 yards per second. When you solve this equation, sorry about that. When you solve this equation, it will come out to be 107.3 yards.